Hello everyone. This video will be on the 3.8 section of the IBAA curriculum. Please pause the video for a second to look at the concepts and contents for this section. There's no formula. One sentence that summarizes this section is trigonometric equations can be solved both graphically and analytically. Let's first talk about the meaning of the equation. Remember from the topic 2, we looked at various quadratic or other functions and we solved the equations of them. Graphically, we can graph both sides of the equation and find the points of intersection and solve the equation. We'll do that first, and then we'll go on to the analytical solutions. So first, let's try some examples given here. Let's look at the second one, 2 sine 2x equals 3 cos x. So we'll open up the graphing calculator and simply just type in all the values. 2 sine 2x. And then on the second line, we're going to write the right-hand side, 3 cos x. Right, let's graph it. So obviously, we can see two graphs, 2 sine 2x and the 3 cos x. We're looking for their points of intersection. However, the question limits our domain from 0 to 180 degrees. So let's do that by changing the window. So 0 to 180. And of course, there's a problem. Why? Because right now the calculator is in the radian mode, but whereas the question gives us 0 degrees to 180 degrees. Right? So let's, after this loading is finished, we'll change the mode into degree, and then we'll solve this question again. Let's quit, and then mode, look at the degree on the third line. Let's press enter, and let's graph again, which is far better. See a good smooth graph, and we see some intersection points. And it's hard to see, so let's change the window again. Perhaps we'll change the x scale to something like 30. And then y min and y max, let's change to like -2 and 2. This is a lot easier to see. We can simply do second calculate number 5, which is intersect. Let's look at the intersection points. It seems like there's an intersection point near here. Enter, enter, enter. So we can say, okay, the first intersection point seems like 48.6 degrees. And then we can repeat the process to find second and third intersection points. Because of the periodic nature of the trig equations, there may be multiple answers, even within the given frame. If we don't limit our domain, there are an infinite number of answers, so we have to be careful about that. Okay. All right, and so now let's move on to the analytical solutions. So what if I'm trying to solve this without a calculator, right? So let's try with the easy one, 2 sine x equals 1. Well, basically the first thing that we have to do is that we simply have to isolate the x, right? So let's do that. Well, my first thing will be dividing both sides by 2, sine x equals 1 over 2. And then my next step would be, I have to isolate x, which means I'm doing arc sine of 1 over 2. Right? We can leave the answer like this, but let's take a step further. And here we need to remember our unit circle from the section 3.5. If you remember, the arc sine of 1 over 2, well, if sine x is 1 over 2, that means my opposite is 1 and my hypotenuse is 2. Or we can say our opposite is 1 over 2 and our hypotenuse is 1. So I can draw a triangle like this, where the opposite is 1 over 2 and the hypotenuse is 1. Well, what's the angle for this triangle? Well, obviously, this is one of the special triangles where this angle is pi over 6. Right. So we can say that, well, arc sine 1 over 2 is simply pi over 6. Right. Are we done here? Well, no. because for sine x equals 1 over 2, there's another answer possible, right? What if I go like this? I can make a similar triangle here, where the opposite is still 1 over 2 and my hypotenuse is 1. So there are two possible answers. And this one will be, obviously, this is pi over 6 here. So pi minus pi over 6 will be 5 pi over 6. Are we done here? Well, not yet, right? We have to be careful because of the periodic nature. If I go one full circle around, then I'll get another sine x equals 1 over 2. Well, one full circle is 2 pi, so whatever number of 2 pi's I do, I'll still get the same answer. So instead of writing pi over 6 and 5 pi over 6 like this, let's add some amendments to it. Pi over 6 plus 2n pi, and then 5 pi over 6 plus 2n pi. So plus 2n pi represents even no matter how much circles I do, how much repetitions I do, I'll still get those same sine x equals 1 over 2. However, because the question limits our domain from 0 to 2 pi, well, 0 to 2 pi is one full circle, so we'll have to delete the extra. So my answer will be x equals pi over 6 and 5 pi over 6. Okay. So if the question gives me, okay, solve for x from 0 to 4 pi, for example, then I'll have to include pi over 6, 5 pi over 6, and then the next one will be about 13 pi over 6, and then 17 pi over 6, for example. Okay. All right, so let's move on to the next section, which is equations leading to quadratic equations in sine x, cosine x, or tangent x. Okay, so if you look at the example on the number first one, 2 sine squared x plus 5 cos x plus 1. Well, first I see a square, so that kind of gives me some headache. And also there's a sine x and also there's a cos x, so I don't like it, right? So let's try to fix it. At this point, I think we can use the trig identities that we learned in 3.6. Right, to go from one form to the other. Okay, so let's quickly review those. Well, I know that because we're looking at sine squared x plus 5 cos x, we can either change the cos x into sine x, or we can change sine squared x into cos squared x. Okay, let's take the latter choice. So I'm going to try to use the Pythagorean identity where cos squared x plus sine squared x is 1. In other words, sine squared x is the same as 1 minus cos squared x. Okay, so let's do that. I'll first start by writing the same answer, and we'll substitute by 1 minus cos squared x. Let's quickly just write it down, Pythagorean. And that. Right, and simplify this one will be negative 2 cos squared x plus 5 cos x plus 3 equals 0. At this point, I think we can factor this. We can say, by the way, if you're confused by this, let's do a substitution. Let's say u equals cos x. It just helps our thinking of it. Negative 2u squared plus 5u plus 3 equals 0, where this is negative 2u, and it seems like I should do negative 1 here and negative 3 here. So it becomes plus 6u minus u. Well, now at this point, we can just substitute our cos x here. Negative 2 cos x plus negative minus negative 1. And cos x minus 3 equals 0. And we know that we can say, oh, we can have two equations. Cos x minus 3 equals 0, and negative cos x minus 1 equals 0. Well, I know that cos x minus 3 equals 0. We could write it as cos x equals 3. And at this point, you should know that cos x equals 3 is an impossible equation that has no solutions. Why? Because cos x, the amplitude is from negative 1 to 1, right? So it'll never reach positive 3. So we can just delete this part. We don't need that. And we're going to focus on the first one, negative cos x minus 1 equals 0. And then we can solve the similar thing that we did previously. Cos x equals 1, negative 1 over 2. And also, let's draw a unit circle again. Well, if we're looking for the negative 1 over 2 for a cosine, well, and then sounds like we have to have a negative adjacent, right? Because hypotenuse can't be negative. So it'll probably a triangle like this and also a triangle like this. They both have the adjacent of negative 1 and the hypotenuse is 2. Well, we can always do negative 1 over 2 and then hypotenuse is 1. If that makes our life easier. Well, we know that this is also a special triangle where the angle, this small angle is pi over 3. That means one of the angles should be 2 pi over 3 from the fact that pi minus pi over 3 is 2 pi over 3, and our all the way around angle should be 4 pi over 3. So we can conclude that x equals 2 pi over 3 plus 2n pi, 4 pi over 3 plus 2n pi. And the question wants our answer to be between 0 and 4 pi. So we know that 4 pi means 2 rotations. So I can conclude that x equals 2 pi over 3, 4 pi over 3, and then 1 full circle, which means we add 2 pi to 2 pi over 3, and which should be 8 pi over 3, and then 10 pi over 3. Okay, and then we can verify that using the graphing display calculator. Let's quickly graph the question. It'll be 2 sine x squared and plus 5 cos x plus 1 we're not seeing right now anything. Okay, it's hard to see right now because again we have our mode in the degrees. So let's change that into our mode into radian, and then we'll change the window from 0 to 4 pi. And the x scale would be, let's put it as pi over 2. Okay. And we see that it should be equal to 0. So in other words, we're looking for the x-intercepts, right? So I can calculate 0 to find x-intercepts. Let's check this one, the second one. Left bound, right bound. We get 4.19, and it theoretically should be 4 pi over 3. So let's just quickly check that. 4 pi divided by 3. So we say that's the same value, and thus we know that we have the right answer. I hope you enjoyed this video and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.